Morning, SCDS. I have 7th and 8th grade up here to share what they did during their week of code. How many students did some coding in the week before we went on winter break? Raise your hand. So you can see a lot of representation in our 5th to 8th grade, which is awesome. And this is the second year that I've had students in 7th and 8th grade do a programming project. And I give them the time during the week before break, 5 hours, to code in class. And then if they'd like to, they may code more, and you'll hear a number of folks did that. I would say at least 50% of students. And one of the reasons that we look at coding and computer programming is not just because it's current and it's what's going on and kids kind of enjoy it in many cases, but because of the qualities needed by programmers. We had a couple of guest speakers come, and the questions I asked them, and these are people who are professional programmers, are what are the qualities or characteristics that a programmer needs? And you're going to notice some things in common with Chloe's 3 rules she shared with us. But this is what they said. Be curious, be stubborn or persistent, know how to ask questions, and then have the courage to be wrong, admit mistakes, ask for help, and say, I don't know. I love these because they fit perfectly with the qualities you need to be a scientist, but also the qualities you need to be a learner in this world. And you may notice they fit really well with our guiding principles. So I love it when all those things come together in a really obvious way for me as an adult, but I also see it in the kids' presentations. The other thing I love about this project is that it allows students, after reflecting on their experience, to use their reflection to come up with a structure and a script for their presentation. And I was incredibly proud of 7th and 8th graders this year. Best presentations I've seen across the board, period, of any project. So that's really neat to see students increasing their skills in that area. And now I shall turn you over to my awesome 7th and 8th grade representatives.
Okay. In my game, platform to platform, you have one objective: to get to the other side. While it may look easy, I will use everything I can to try to stop you in every level, from simple obstacles to complicated puzzles that can require much time just to get the right idea about it. It all works on one principle. When it is touching a color detected from the background I drew, then do blank. In the code you see right here shows that if you are touching green or black, the colors I chose to represent a ground point, then change Y by 1, then, if you are touching green or black, change Y by 1, etc. It may look like you are on solid ground, but you're actually just modulating up and down so rapidly that you're able to count that as solid ground. So I give you a challenge. Can you make it to the end, bask in glory? Or will you fail, falling into the abyss? Find out now on Scratch.
According to my mom, the app I created is too hard for adults. I decided to do this project because I've always been interested in how reflexes work, how fast they are, and how fast they can be. This part of my code lets the user know how many times they have clicked on the screen. The score will consistently go up by 1. To score, the user must click on the ball which is going across the screen at random. The user must click on the screen to make the scoreboard text go away. The scoreboard text will give the user brief directions on how to score in my app. Using Bitsbox, everything has to be perfect for your code to work. Does the parentheses contain the right code, or is the comma in the right place? I faced all of these problems during Week of Code. I also spent over 7 hours on this project in and out of school. Thank you.
I challenge you to beat my game, or do you not have the skill? Some of you may know what Pong is, but for you of those that don't, it is a game where a ball moves randomly around a screen and you try to keep it bouncing off your paddle and not let it touch the bottom of the screen. I picked this game because it was one of the first games I've ever played and I wanted to see and know how it worked. The most challenging part of the project was trying to make the timer and score counter work. The challenging thing about making the timer and score counter work was making the correct program run at the same time as my main program and actually pick up the time when the ball bounces off the paddle and to add a point to the score counter. I was most proud of making the score counter and timer work. The score counter was the first upgrade I wanted to make for my game, but in the end it turned out to be the hardest one out of the two to get working. I spent a couple classes trying to make it work until I finally had some help from friends and the Scratch's Pong tutorials. In total, I spent 5 hours and a little bit more working on all the parts in my program. I changed the programs over and over, trying to find the one that worked best for me. I also learned a lot during this project while working with the codes and getting through my frustrations and turning them into happy successes. You can find and play all of our games by searching the SCDS tag and Scratch website. Thank you.
Hi, I'm Ben, and to present my programming project, I created a video.
Do you want the thrill of winning the lottery, but don't want to spend lots of money on tickets? Come and play Ben's Lottery Game. With increased odds of winning, you can win, no matter how unlucky you are. Hi, I'm Ben Alexander, and I'll be showing you some of the steps and concepts I learned during my programming project. One function I use a ton in my coding is if-then-else conditional. I use it to detect whether the player has won or not. My two random numbers are defined as A and B. When it detects, it says if A is equal to B. Then there's a colon, which represents then. Everything indented afterward is what the program will do. If A does indeed equal B, then the program will display they match, you win, plus $40. Then it updates the money variable. In order to make the program faster, it only updates the .txt when you ask to close the program.
The video you see here is a shortened version, but you can find the full version on the SCDS YouTube. I also used this video to apply to Tech High.
Imagine that you are in the beautiful countryside. You look out and see the rolling green hills and the clear blue sky. You take in a deep breath of all the clean, fresh air. Nearby, you see a bountiful apple tree full of perfectly red, crispy apples that you can't wait to get your hands on. Everything is still and peaceful. Then suddenly, out of nowhere, you hear the sharp roar of a chainsaw and are sent into an immediate panic. You must protect yourself from this dangerous object and, of course, get some of those delicious apples you spotted earlier. During the week of code, I used the website WeScheme to create a series of 3 games titled Chainsaw Chase. In the first edition of my series, Chainsaw Chase 1, you play as Porky the Pig. To play this game, press the right, left, up, and down keys to move on the screen and to retrieve those delicious apples. But beware of the chainsaw and avoid him as much as you can. Press the spacebar to shoot out pieces of bacon so you can hit the chainsaw and protect yourself. In the second edition of Chainsaw Chase, titled Chainsaw Chase 2, Return of the Chainsaw, you play as Sirloin the Cow and retrieve ears of corn to earn points and shoot out hamburgers to defend yourself. In the final edition of Chainsaw Chase, titled Chainsaw Chase 3, Chicken Strikes Back, you play as Shicky the Chicken as he takes his stand against the evil chainsaw. This time, your job is to retrieve as many ladybugs as you can, and as usual, stay away from the chainsaw. By pressing the space bar, you can shoot out buckets of KFC chicken and hit the chainsaw to eventually win. One really important line of code that I used to make my games was the scale function. The scale function does exactly its name. It's used to properly scale each of the different elements of your game. For example, when I originally put the target and player into Chainsaw Chase 1, the player was much smaller than the target, and I needed them to be more equal in size. Using this function, the programmer can scale up and down, assuming the current scale of the object is 0. And here are some actual lines of code that I wrote using that function. Thank you.
Okay, for the week of code, I decided to continue taking lessons with a website I used last year called CodeHS to learn about simple graphics and text. CodeHS teaches a coding language called Java that is now being used widely all over the world. Google, for example, has made Java their main coding language for their Android phone operating systems. During a course of 8 lessons, I learned how to ask for apples and oranges through user input and then compute the sum, and how to make a magic 8-ball that unfortunately can't do anything except for appear on the screen. Hopefully, when I try coding again, I'll be able to make it tell the future. I had an especially fun time learning about variables in coding. I like to think of variables as boxes with names that relate to the value they hold. In this example, this variable, numapples, holds the value of 5 apples. This line here was code that I used to make the white stripe on the French flag. The code creates a new variable called white rectangle that holds the value of a rectangle with the width of 500 and a height of 250. The end result of the flag looked something like this. Over the course of the week of code, I did have some struggles with CodeHS where the code refused to work, and I forgot one of those dreaded semicolons at the end of one of my lines of code. I ended up like this more than a few times. But with a little help and perseverance, I learned a lot more about coding in Java, and I'm sure that everybody else who did coding learned a lot too. Thank you so much.